This is the fifth part of our class. This is the fifth part. So today we'll be talking about the collision, which is usually of two types. One is the elastic collision and another one is the inelastic collision here. So we'll say collision here. Okay, the definition and I'll not explain in that way. And if there is some simple physical contact between the two bodies, then what we can say that the two bodies are in collision. So mathematically, let's come to the point. Suppose here is a body of mass m1, and this is moving with initial velocity u1, and here is another body whose mass is m2 moving with initial velocity of u2. If they happen to collide after collision, then this will be mass will remain the same, but velocity will be transformed here. So m1, m2, these are the two bodies, but the velocity will change to v1 and v2 respectively here. Then from the law of conservation of linear momentum, we can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is from the law of conservation of linear momentum. Okay, now we'll see the types of collision. The first one, we have this elastic collision. There are certain characteristics of elastic collision. In the case of elastic collision, both this momentum and kinetic energy will be conserved. And some of the basic characteristics. The first one is momentum is conserved. The second one is the kinetic energy is also conserved. And number three is total energy is also conserved here. And the forces involved, whatever the force involved here, the force also remain conserved. At the same time, the mechanical energy is not transformed in any other form. For example, say like transformation of this mechanical energy into some other form like heat energy or sound, there is nothing like that. So there is no transformation of mechanical energy. Then this type of collision is said to be elastic collision. In the case of the second one here, inelastic collision, here only the momentum is conserved here, only momentum is conserved, whereas this kinetic energy is not conserved. So this is the main difference between elastic and inelastic collision. Now, so this derivation is a very lengthy one. I'll not do all the derivation, I'll just highlight the important formulas only. Now let's take the case here, case of elastic collision in one dimension here. In this case, let us consider the same case again as before. m1 u1, this is the second mass m2 u2. After collision, this mass remain the same, m1, but the velocity changes to v1. Second mass, velocity changes to v2 here. Then from the law of conservation of linear momentum, let us rewrite again m1 u1 plus m2 u2. This is going to be m1 v1 plus m2 v2. Alright, so on factorization by multiplying by half on both sides here, 1 by 2 on factorization, you will get this formula, v1 is equal to m1 minus m2 u1 divided by m1 plus m2 plus twice m2 u2 divided by m1 m2 here. This is the velocity after collision for the first body. This v1 will be given by this equation. Okay, and the second body, this body for mass m2, the velocity after collision will be given by v2 is equal to twice m1 u1 divided by m1 plus m2 plus m2 minus m1 divided by m1 plus m2 u2. Okay, this will be the velocity of the second body here. Remember, I'm not doing the derivation. Derivation is not going to be important for NEET examination. That's why I just skip the derivation portion here. Okay, this is the one, and there are certain special cases, like when the two bodies are having the same mass, and when the second body is at rest, this and that, but I'll not be covering up all those cases. I'll just take up the cases only when we solve the numerical examples only. Okay, this is the one, and there is another derivation for this perfectly inelastic collision here, and that one also is a very lengthy one, so I'll not be covering up that one. But in the case of perfectly inelastic collision, in the case of perfectly inelastic collision, what we have to know is that the bodies after collision, they will be moving with a common velocity. For example, say this is the first body A, mass is m1 u1, second body B, mass is m2 u2. After collision, they will stick together. This is your m1, this is m2, and they will move with a common velocity here. And if this condition is satisfied, then the type of collision is said to be perfectly inelastic collision here. But here we have to know a very important equation that is known as coefficient of restitution. Coefficient of restitution here, and this is applicable in the case of perfectly elastic collision. I repeat again, this is for perfectly elastic collision where the two bodies don't stick together. The first case we have taken for perfectly elastic collision, like this type of collision here. In this case, the coefficient of restitution, the formula is given by E is equal to the relative velocity of separation after collision. After collision, the relative velocity of separation will be v2 minus v1 divided by the relative velocity of approach here. Means that for approaching, the two velocities are u1 and u2 here. So here will be u1 minus u2. This is the equation that we have to use for coefficient of restitution, especially for numerical calculation. Let us see this question number 5 in the book. Question number 5 reads like this: a ball of mass m moving with a speed of v makes a head-on collision with an identical ball at rest. The kinetic energy after collision of the balls is 3/4 of the original kinetic energy. Then we have to find the coefficient of restitution. Okay, let's try to solve this question again here. The ball is moving with a mass m here. Let's solve this one. Before you apply this concept directly, let us go to the basic again. Say this is the mass m1, but the question says that the two colliding bodies are having the same mass. So let's take only m here, moving with initial velocity u1, the second body of the same mass m. this is going to move with u2. Then after collision, after they collide, the mass remains the same, velocity is transformed into v1, and for the second case, m transform into v2 here. Okay, this is the one. But in this question it says that the body is approaching with a velocity of v, means that this is v, so u1 is going to be v, and the second body is at rest, so u2 has to be 0 here, and the other two cases remain the same. So now if we apply the law of conservation of linear momentum, our original equation is m u1 plus m u2. This is going to be m v1 plus m v2 here. Okay, if you apply if you replace this one, u1 is going to be v, so you can write mv plus this is going to be 0 is equal to m common, you have v1 plus v2. On cancellation you have v is equal to v1 plus v2 here. This is equation number 1, let's call it. And the question, come back to the question now. Question says that after collision the kinetic energy is equal to 3/4 of the original kinetic energy. So after collision, this is the part you can, after collision, your kinetic energy after collision here. So this kinetic energy after collision, this is equal to 3/4 of the original here. So the kinetic energy for the this case after collision is half of mv1 square plus half of mv2 square. This kinetic energy after collision is equal to 3/4 of the original here. And keep in mind, in the original case this is already equal to 0, so combination velocity for the both of them together will be only v, because this one is approaching here, this is for at rest. That's why kinetic energy before collision is half m. Keep in mind that another one is at rest, that's why kinetic energy is equal to 0. So for the approaching body is what, v, half of mv square. This is 1. Will cancel at one time, so you have this half v1 square plus v2 square. This is equal to 3/4 half v square. Half of cancel again, so you have v1 square plus v2 square is equal to 3/4 of v square. Let's call equation number 2 here. So from here, let us try to remember the formula that we have written for the coefficient of restitution. For the coefficient of restitution, E was equal to the relative velocity of separation. It was v2 minus v1, and the relative velocity of approach, it was u1 minus u2. So in this case also you have this v2 minus v1 divided by this, the second body u2 is equal to 0. So only u1 will be left here. So when you multiply, cross multiply, you have v2 minus v1 is equal to E times of u1. But you know that this u1 is equal to v, so we can write v2 minus v1 is equal to v here. This is equation number 3 here. So you have got 3 equations. We'll be using these 3 equations and we'll try to find out this value of E here, coefficient of restitution. Now let us try to factorize the 3 equations here, 1, 2 and 3. So 1 is plus, 1 is minus, so let us do squaring on both sides of equation number 1. If you do squaring on both sides of equation number 1, you have b square is equal to, if you do squaring on both sides, you have this v1 plus v2 whole square becomes a square plus twice ab plus v square here. This is what you get. is equal to, and this one v1 square plus v2 square, already got a value here. I mean these two terms you can put in here. So you have twice v1 v2 plus, instead of this v1 square plus v2 square here, you can write this equation number 2. So it becomes 3 by 4 v square, like this. And you have got one more equation, this equation number 3. Let us do squaring one more time here. Squaring equation number 3, we get e square v square is equal to v2 minus v1 whole square. So this will give you v1 square here. This is what you get. So putting this value again, v2 square minus 2 times of v1 v2, 2 times of v1 v2, did you put anywhere? Okay, no problem, you can find out this value here. From here you can put in here also. Okay, so let's try to find out this twice v1 v2 first from this equation here. From here, if you find this twice v1 v2, this will be 1 minus 3 by 4 v square here. So 1 minus 3 by 4, you have 4 minus 3 by 4, it gives 1 by 4. Okay, this will be v square by 4 here. So instead of this twice v1 v2, you can write this v square by 4. So v2 square minus twice v1 which you can write v square by 4 plus v1 square here. You can write in this way. This is e square v square here. Okay, and one more here, you have this v1 square plus v2 square, you can write again. Instead of this v1 square plus v2 square, you can put in this equation number 2 here. So it should be looking like this, 3 by 4 v square minus v square by 4 here. Okay, so this is equal to this v square taken common here, 3 by 4 minus 1 by 4. This should give you v square by 4 here into 2. Yes, v square by 4 into 2. So this is going to be v square by 2. Okay, so you have e square v square is equal to v square by 2. So v square cancel. So you have e is equal to square root of 1 by 2, which is equal to 1 by root over 2 here. So this is the value. So your answer should be 1 by root over 2. This is your answer. Should be C should be the answer here.